everyone, welcome back to the channel. In today's live we'll be going through the June 2018 Paper 1 higher tier Edexcel non-calculator paper. I've linked it in the description, so if you want to open that you can see that in the mark scheme. I've also linked in the description if I've made any videos on the topics that come up in this paper, then they're all in the description there. So we will get started as soon as you guys are ready. So obviously non-calculator, because this week you've got on Thursday your non-calculator paper. So we've got another really common question at the start. I feel like this, speaking for Edexcel, comes up so much. We've got some form of fractions operations, and it seems to always be mixed numbers as well. So this is you definitely want to make sure that you know how to do. So we've got work out 2 1/7 plus 1 1/4. Now you can add them as they are if you want, as in the 2 and the 1 and then the fractions separately. I prefer to just basically convert everything into a from mixed numbers into an improper fraction, because then that's consistent for multiply, divide, add, subtract, it's all the same. So I would prefer to convert them. So I'm going to basically multiply the whole number by the denominator. So 2 times 7 is 14, plus the numerator is our kind of remainder, isn't it? So that'd be 15 over 7. And then for the second one, 1 times 4 is 4, plus 1 is 5, so 5/4. Now that I've done that, I'm obviously going to go through and add them. Obviously, I need to have a common denominator. That's the same for if you have a subtract as well, you need a common denominator. So the common denominator, I would probably choose 28. I think that's the smallest you can go, isn't it? 28. Okay, so 28, we need to change the denominator. The first one, we need to times it by 4, so obviously same to the numerator. 15 times 4. I would recommend, if you can, familiarise yourself with the 15 times tables and the 16 times tables, just up to like 5 or 6 times 15, 5 or 6 times 16, because that seems to come up a lot in Edexcel. Seems to come up a lot for non-calculator. So 4 times 15 is obviously 60 over 28. Plus the other one would obviously be multiplied by 7, wouldn't it? So we've got 35 over 28. Now I can literally just add them across. Add the numerators, not the denominator, it's still over 28. Now this one hasn't specified how to leave it. It hasn't said whether it needs to be an improper fraction, mixed number, simplified, anything like that. So you can just leave it like that. Or if you make it into a mixed number, that's also fine. If you put that, or you could put 3. I don't think it simplifies, but it would become a mixed number. You can put either of those, that's fine. So what's the way to do it with the whole numbers? So what I mean by that is you can separate it out if you want to. I don't normally do this, but if you wanted to, you technically can. But this only works for adding. Sometimes it works for subtracting, it depends on the fractions, but it doesn't work for multiplying and dividing, which is why I tend to just stick to one consistent method for all of them, if that makes sense. So for example, do you see how I've separated them? I could just do obviously the 1 plus the 2, which is 3. Or 2 plus 1 is 3. Ooh, you see, I've got 3 here. And then if I did separately the 1/7 plus the 1/4, now you'd obviously still need to have a common denominator. It would still be 28. But the only thing that avoids is, you see how we ended up with quite big numbers, 60 and 35? That would avoid having such big numbers in numerators, because obviously that one would just be multiplied by 4, which is 4 over 28, the other one by 7, 7 over 20. Do you see what I mean? Like, they're not as big a numbers. And then you see how I get 11 over 28 as well. And then you would just piece it back together. So you can do it that way if you want to. But as I said, it works for adding. It sometimes works for subtracting. It just depends, because let's say if your second, like in this case, obviously the quarter is bigger than a 7th. So if you were to subtract those, you'd get a negative, and then it's a bit messy, isn't it? but also multiplying and dividing, it doesn't work for that. You'd have to convert them into improper fractions. So personally, I like to just stick with converting everything to an improper fraction, and then if I need to convert back at the end, I will. For this part A, they didn't say that you had to convert it back, so either of these two answers is fine. 95/28 or 3 11/28 is fine. Okay, but I'm trying to zoom down, but it's gone smaller. Yeah, so this always comes up, I feel like some version of this, right? Some version of fractions operations always comes up in the non-calculator. So make sure you know how to do each type: add, subtract, multiply, divide. Obviously here we have a divide, so work out 1 1/5 divided by 3/4. Give your answer as a mixed number in its simplest form. So you see how this one has actually specified how to leave it, so you would have to leave it in that format. So I'm going to convert the first one into an improper fraction. So 1 times 5, whole number times by the denominator, and then add the 1. So you get 6/5. The other one is obviously fine, isn't it? Divided by 3/4. Now, obviously for divide, we do keep flip change. So keep the first one, flip the second one, and change it to a multiply. Now, obviously, I'm just going to multiply straight across. So the numerators is 24, the denominator is 15. Now I've got this though, because they did say not only mixed number, but also simplest form. You can do kind of either one first. You could convert it into a mixed number first and then simplify it. You could simplify it first and then convert it into a mixed number at the end. That bit doesn't really matter. I probably do, I guess if you do it into a mixed number first, then simplifying it will be a little bit easier. So how many 15s go into 24? 1. Remainder 9. Now obviously then I would simplify this fraction, right? 9/15, that's a little bit easier to simplify. You should get 1 3/5. So nice 4 marks to start with. Question 2, we've got ratio. So in a village, the number of houses to the number of flats is in the ratio 7:4. So house to flat, 7:4. The number of flats to the number of bungalows is 8:5. So that's overlapping on the flats section bit, isn't it? That's overlapping. There are 50 bungalows in a village. How many houses are there? There's different ways to do this. I personally like to make it into a 3-part ratio and then work out the 50. You could do it without doing that. You could do it straight. It's up to you. I like to make it into one whole ratio. So like this. So you see how I've got 7:4, and then overlapping on the flats is 8:5. So you would need to look at the flats and find a lowest common multiple. In this case, it's quite easy, right? Do you see how 4 and 8, obviously one's multiple of the other? So I would just double the second one. Do you see if I just multiply this one here, obviously that would become 8. The 5 would stay the same, but I would also have to double the 7, 14. That's my whole ratio. Now what I would do is then I would line up. I like to just look at it vertically. That's just me. You might prefer to lay it out differently. I know there's 50 bungalows. You see the difference here? They've obviously multiplied by 10. So they said, how many houses are there? Well, just times that other one by 10, 140. Obviously there would be 80 flats, but we don't technically need to know that. 140. So however you wanted to do that, there's definitely different ways to do it. You might have done it differently to me. As long as you get the answer 140, then that's absolutely fine. So nice 3 marks, I think, for that one. Okay, question 3. Renee buys 5 kilos of sweets to sell. She pays £10 for the sweets. Renee puts all the sweets into bags. She puts 250 grams of sweets into each bag. She sells each bag of sweets for 65p. So Renee sells all the bags of sweets. Work out her percentage profit. So percentage profit is the same formula. Oh, if you want to have a look at the other way. The other way, I think some people would have done it like... just looked at it separately. So for example, obviously we know the bungalows, right? So it's taking the bungalow one, so that's 8 to 5, isn't it? bungalow to flats, they might have done this. They might have just lined it up immediately and gone, okay, well, that means there's 80 flats, and then jumped to the other one, because obviously flats is where it overlaps, isn't it? So that was 7 to 4. And then gone, okay, well, there's actually 80 flats. So how do I go from 4 to 80? That's obviously times by 20, and then they times that by 20. So do you see how they wouldn't have... You can do it without creating a 3-part ratio. You could do it separately and just make the leap between the 2 ratios. You can also do that. So yeah, a lot of these, there's different ways to do it. It just depends what comes to you first. And if you get the same answer, then it shouldn't really matter, should it? So yeah, what I was saying about percentage profit is it's the same formula as percentage change, except obviously just more more relevant to the context. So the formula is the profit, so the physical profit, which is the same as like the difference, the change, over the original, which is the cost, because you would have had to buy the sweets before you can then sell the sweets, right, in terms of a timeline. Obviously then times it by 100. So that's the pieces we need. So in order to find the profit, you obviously have to subtract how much you sold it for and the cost. So obviously then the thing is that we know the cost in terms of the whole 5 kilos is £10, but then they only told us 65p each bag. So we'd have to kind of, well, you could convert it either way, I guess. You could work out the cost for each bag. I like to just work out the total cost personally. So let's see. So 5 kilos, how many 250 gram bags would go into 5 kilos? Obviously that's 5,000 grams, isn't it? I just worked it out because I went, well, I know there's 4 250s in 1,000, so then that's 20, isn't it? Yeah, exactly. It's exactly the same as that formula. Change divided by the original times 100. Do you see how profit, the context, it's just got more of a context, isn't it? The context is the profit, which profit is the change, isn't it? It's the difference between the sales and the cost. And then over the cost, which the cost is the original. If you think about a timeline, you have to buy something before you can then sell it normally. And then obviously times by 100. So it's exactly the same formula, just in this context, basically. So I'm going to work out how many bags there are. Obviously, you can knock off if you want. You could work out however you want. But either way, there should be... I know that 250 is going to 1,000, so times that by 5 should be 20 bags. So she sold 20 bags, and she sold them each for 65p. 20 times 65. The way that I did it is I knew that 2 times 65 was 130 or £1.30, times it by 10, so that's basically £13 or 1,300p, I guess. So that's her like sales, isn't it? That's her revenue. So the profit, you don't necessarily have to write all of this down, I'm just kind of showing you, would obviously be the sales minus the cost. So you can see that's obviously £3, isn't it? Which is the same as the difference, the same as the change, isn't it? So in terms of our percentage profit, £3 divided by the original or the cost, which was 10. Obviously it's non-calculated, so they've chosen some nice numbers. That's 0.3. Obviously that's 30% basically, isn't it? 30%. So yeah, percentage profit is basically the same as percentage change, just with a context. So that's quite nice. And 4 marks for all of that as well. That's just more kind of, yeah, percentages, but kind of general maths, isn't it, that question? Multiplying, dividing, adding, subtracting, that kind of thing. So yeah, 30% for that one you should get. Okay, question 4. What I have noticed is I feel like there's a fair amount of speed, distance, time in non-calculated papers. I don't really know why, but there seems to be a fair amount of speed, distance, time type of questions. So here we've got a cycle race across America is 3,069.25 miles in length. Juan knows his average speed for his previous races is 15.12 miles per hour. For the next race across America, he will cycle for 8 hours per day. Obviously, given the numbers, we're going to estimate how many days Juan will take to complete the race. So it's going to be an estimation. So they've combined the topic of estimation with the topic of speed, distance, time. 2 for 1 basically. So you round it normally, well, yeah, sometimes you round to 1 decimal place. You can round to 1 significant figure. You can round it to whatever you want, really. They've given multiple options in the mark scheme. What I rounded it to was, obviously that one I would just round straight to 3,000. I wouldn't even do 3,100. I would literally just round it to 3,000. This one obviously, what was that, miles? This one I would round to 15. Some people, I think you can round it differently, but I rounded it to 15. What's that, miles per hour? Okay, and then 8 hours, you can round the 8 to 10 hours if you want. I think 8 isn't that bad to work out, so I just left it as 8 hours. But you could round it to 10 if you wanted to. So what way would I have done it? I think, again, there's different kind of orders to how you could work this out. The order that I did is I just said, right, well, he's cycling 8 hours a day. How far is that? That's kind of what I worked out. So I went, okay, 15 miles per hour, 8 hours, and multiply them. Then it's just like times 10 times 5, isn't it? So it's like 1.5 times, really. So that should give you 120. It's not too complicated to work out. Now that's how many miles he can cycle per day. So then I thought, okay, well then how many days would that be? So that's obviously 3,000 miles divided by 120. So I knocked off the zeros. 300 divided by 12. Yeah, you might have preferred to have times that by 10 and then had 150. It depends. I guess we could do bus stop, but couldn't we? It's not too complicated. So 12 into 30 would be twice, so the remainder is 6. 12 into 60 is 5, so that's 25. I personally got 25. They said they would allow for 20. You wouldn't get the same answer if you rounded differently, no. They said, that's what I'm saying. They would allow for 20 or 25. If, let's say, you rounded this bit to 10 hours, obviously you'd do 15 times 10, which is 150, and then this answer would be, I think, 20. So if you rounded that one to 10 hours, that's fine. They allowed that as well. So yeah, they have allowed different answers in the mark scheme. Let me have a look at the mark scheme. See if they've said anything more specific. It's gone there. Question 4. Yeah, they've not given an actual answer in the mark scheme. They've just said a mark for your estimated value, if you know what I mean. As long as you've done the correct kind of calculations. Did you work it out exactly? 3,060. I wouldn't have worked it out exactly, because also the fact they did say estimate. So I think you would have had to round it. Like you do have to round something. It just depends how you want to round it, if that makes sense. But because they did say estimate, they don't want you to work it out exactly. They want you to give an estimate, like an estimate. So yeah. Let's see. Well, I don't know. I mean, they have said accept it if you did it exactly, but I just don't know why you would. Yeah, I have a video on vectors. Yeah, like 2 or 3 videos. Yeah, I've got videos on vectors. Have a look through my channel, or have a look through like the higher tier playlist. AQA. I mean, look, AQA, the topics, like the syllabus, is basically the same. So the content is the same. What I would say for AQA is that they word their questions very differently and they lay it out differently. And maybe their mark scheme, like what they're looking for in the mark scheme, is different. So in terms of practicing general maths content, yeah, this is fine. In terms of practicing for your specific exam, if it is AQA, I would, especially because we're quite close now, I would try and stick to AQA papers, if that makes sense. Yeah. So it's still the same content, but I don't know. Yeah, they word things differently. I find AQA is quite difficult to understand how they've worded it. Maybe it's because I'm just used to Edexcel. But I think, yeah, it takes some time to get used to how they word it and what they expect from you. So yeah, I would say I wouldn't work it out exactly. I think that would take a lot of time. I mean, you probably could, but I just think if they said estimate, I might as well just save myself some time and estimate it. So yeah, 20 or 25 or something like that, as long as you've rounded it and then done these general calculations, then they'll accept that. Now we've got part B. So we've got Juan trains for the race. The average speed he can cycle at increases. So it's now 16.27. So previously it was 15.12, wasn't it? Now it's 16.27. How does this affect your answer to part A? Now there was actually kind of 2 possible answers. I guess technically if he's going to cycle faster, it would take him fewer days. That's one option. Fewer days, or your answer would decrease, or whatever you said. However, the other thing you could say, yeah, you could say it would take him less time. Yeah, you could say that. It's effectively kind of the same thing, I would imagine. That's one thing. Or if you're really reading the question, it says, how does it affect your answer to part A? Well, because we estimated, it depends. Because I obviously rounded 15.12 down to 15. Now imagine if you had 16.27, would you have rounded it down to 15 as well? Because if you'd have rounded 16 down to 15, then it wouldn't have affected your answer, would it? At all. If you'd have rounded both of them to the same number, you'd get the same answer. So you could say it would take fewer days, because technically in reality, if he's going to cycle faster, yeah, it's going to take fewer days. But if in terms of your answer, in terms of your working, they have accepted that you could say doesn't affect your answer, because you would have rounded it to the same. If you would have, right? If you would have. As would have rounded. Do you see what I mean? The examples of decreases the answer. Yeah, I would say you'd get, because it says in the mark scheme, it says refers to time taken. I think if you just said decreases the answer, I'm not sure that would be enough. I think you have to relate it to the context. So you said completes in fewer days / fewer hours. That would be the bit that I would say would give you the mark, yeah. Because you've kind of related to the time. You've related to the context. It hasn't said anything that's not acceptable. It's just said their example was exactly less days required or fewer days or something like that. Or it doesn't affect the answer because I would still round 16.27 down to 15. Or if you rounded it up to 20, then yeah. No, it's not about an underestimate or overestimate. Sometimes that is the question, isn't it? Is your answer an underestimate or an overestimate? Sometimes that's the part B. In this particular question, it's not the part B, but sometimes, yeah, it is. So you don't need to talk about that, I don't think. Okay, so yeah, they haven't. Sometimes they give examples of not accepted answers. They haven't in this case. They've just said what they would accept. Yep. Okay, this one I've zoomed out just because we need to look at the grid at the same time, but hopefully you can see it clearly enough. So here is a solid square-based pyramid, which is just key there because I feel like it doesn't really look like a square, does it? But it is apparently a square-based pyramid. The base of the pyramid is a square of side 6 centimeters. So that side there is obviously also 6. The height of the pyramid is 4, the vertical height. M is the midpoint of BC, and VM is 5 centimeters. So kind of like the slanted height, I guess, is. If you round down, if you round down, is that an underestimate? It depends on the question. It depends what your formula was, I guess. Because if you're dividing or if you're multiplying, that can affect if your answers are. Do you know what I mean? It depends on the formula. It's the same as, when you do upper and lower bounds, and sometimes you need both upper bounds, both lower bounds. Sometimes you need one of each to get a different answer. I don't know. So I think it would depend on the formula. In this case, I'll just quickly go back. Let's think about it. So if let's say they'd asked, is your answer an underestimate or an overestimate? I got 25, right? Well, I rounded down the number of miles, so actually it's more miles, isn't it? And I rounded down the number. I also rounded down the number of days, miles. Yeah, I think they didn't ask that in this case because technically we don't know, because unless you obviously worked out exactly, which we won't do. But I rounded down the number of miles, so technically it's longer than 25 days because the actual reality is more miles. However, I also rounded down how many miles he could do per hour. So in a day, he'd actually do. I worked out 120 miles per day. He actually technically does more than that, doesn't he? Because it's 15.1, I know it's not by much, but 15.12 miles per hour. So it would be more than that. So do you see how, like, I've rounded that down, so it could take longer, but then I've rounded this also down, but then that means it might not take as long. So I think the reason why they didn't ask in this particular case is because it wasn't clear. If they ask, it will be because it's really obvious. So I don't know, you can't really, yeah, they have not asked that one in this case for a reason, because of the different types of dividing we did. Right, so this one, they've asked us to draw an accurate front elevation. So you see where they've, like, imagine you're stood here That's you, stood here looking at it. When they say a front elevation, it's kind of hard to describe, but no, I think, no, yeah, you are right, 6 by 4, because obviously the 6 is fine. That's kind of obvious, isn't it? The 6 is fine. That bit makes sense. Where's my straight line? So you can draw it anywhere on this grid, obviously, just make sure you have enough space. So 6 across 1, 2, 3, 4, 5, 6. Because when you look at it, imagine it was like two-dimensional. Like imagine you just squished it flat. And I don't mean, because you know, obviously this is a slanted side, isn't it? I don't mean if that was to then stand upright. I don't mean that. I mean just literally if you're looking at it straight, across is 6. The height is technically 4, isn't it? Oh yeah, the plan would be 6 by 6. Yeah, you're right. The plan would be a rectangle, not rectangle, well, square, wouldn't it? 6 by 6. The front elevation is just looking at it from the front. So yeah, it is 6 by 4 and obviously a triangle. So what's that? 1, 2, 3, 4. So it'd be like, obviously like an isosceles triangle, right? Obviously the point has to be right in the middle. So something like that. Okay, so yeah, 2 marks that. I don't know if you can see that, but it's 2 marks for that part. Yeah, you can just about see. 2 marks for that part, but yeah, I don't know, front elevation is kind of annoying because you have to really try and figure it out. Part B though, work out the total surface area of the pyramid. Obviously they don't give you the formula for that because it's just different triangles and squares added together, isn't it? So 4 marks, but let's do it in this page so we can actually see it. So this is for part B. Let me move over. I'm just going to move it over so we can write on one of the sides. Here. So this is part B, right? Surface area. So we've basically got, what have we got? 1, 2, 3, 4 sides, and then obviously 1 base, so that's 5 sides. So we need to work out 5 areas. Some of them are obviously then the same, aren't they? Probably the easiest one is a square, isn't it? Might as well start off with the square. Square is 6 by 6, 36. Cool. Now, because it's a square-based pyramid, technically all of the triangles are also the same as each other, aren't they? Area of cross section, that would only, the area of the cross section times by, because what's the cross section? There isn't, like, because it's not a prism, there's no cross section, is there? In terms of like a consistent shape all the way through, it changes. So that would probably only work, I would suggest that would only work for a cube. Like, you know, like a 3D square. That would only work for that. The surface area is basically just individually working out all the sides and adding them together. Now, in this case, the 4 triangles are identical because it was a square-based pyramid. So I can just work out one of those triangles and times it by 4. So you've got, in terms of this is why we need now to use the 5. So the triangle is base times height, so 6 times 5 over 2. Yep, you said 15 exactly. And then obviously there's 4 of those. So 4 times the triangle would be, again, do you see how we got that 15 times table again? It just keeps coming up. So I would recommend, you know, it might be easier if you recognize that. Those, if you're familiar with that times table a little bit. So what have I done now? I've given the answer, haven't I? 15 times 4 is 60. There we go. 4. There we go. Okay, so then we need to add it together with the square. Don't forget we've also got the square. So these two we just add together. So the total surface area is 96 centimeters squared. Yes, exactly 96. You've written that, yeah. Do we have to label the height? I don't think you do in this case. No. I know that we saw a question, I think we saw a question recently where they gave us like the plan and the side and the front elevations, didn't they? And they said draw the 3D shape. That was the cylinder one. So that one we did have to label because I don't think there was a grid, was there? There was just some kind of like open space. But because this is an actual grid and it's a centimeter grid, they can obviously count if it's 6 by 4. They can see that. So I wouldn't have labeled it personally. Volume of a pyramid is the third times. To be fair, I don't know that one off the top of my head. They barely ever asked volume of a pyramid, so I've not even seen a past paper question on it, but I would have assumed that they would give you the formula because it's not a prism. As in for the volume at least. Because they give you a cone, don't they? Volume of a cone, volume of a hemisphere. No, not a hemisphere, but a sphere, a whole sphere. I would have assumed they would give you it, but I can look it up. I don't think, yeah, I think that sounds kind of right. I guess it depends on the base, doesn't it? Yeah. Yeah, so you work out the area of the base, times it by the height, and divide it by 3, or times it by a third, as you said. Third times base times perpendicular height. Yeah, I think that's the formula. I've not seen it come up though, like the volume of a pyramid I've not seen come up. Not to say it can't, but not in any of the past papers, so I don't know if they give you the formula. I would have guessed that they would, but I don't really want to. Yeah, I don't know. I think they would. Sine and cosine rule. They could ask sine and cosine rule in the non-calculator technically, because they would choose, 30 degrees or 60 degrees or something like that. I don't know if it would. I don't think sine rule. Well, sine rule has 2 angles, isn't it? That's even harder. I think it's unlikely. Not to say that it can't, not to say that it's impossible, but I do feel like it's unlikely. I think a lot of the time they like to use SOHCAHTOA, which either just basic trig, or when it's in a 3D shape, maybe they use it in a 3D shape, because that's still SOHCAHTOA, isn't it? I don't know. I couldn't predict on that one. It could come up. It's not common, but it definitely could. There's nothing to stop them, is there really? If they use nice numbers. Yeah, cosine might make more sense because it's only got 1 angle, whereas sine rule technically has 2 angles, doesn't it? So that'd be quite hard. Yeah. Yeah, I would say there is a chance. Probably a small chance, but there's still a chance. Okay, question 6. It's kind of a random question, I guess, just some kind of coordinates, like figuring it out, that type of thing. So we've got a pattern is made from 4 identical squares. The sides of the squares are parallel to the axes, so it's not rotated or anything. It's literally just, horizontal, vertical. It makes it match with the axes. So point A you can see is coordinates 6, 7. Point B is coordinates 38, 36. Up here we need to work out point C. So yeah, you have to kind of look at it, horizontally and vertically separately. There's obviously this awkward overlap vertically, so I would look at it horizontally first, because you have got exactly 2 there and exactly 2 across here, haven't you? So yeah, I would look at it, in this case I would look at it horizontally first. So yeah, working out a difference, 38 minus 6, as you said, gives you 32, but then that's the same as 4 squares, isn't it? So 1 square would be 8, yeah, and because it's a square, obviously it's 8 across and 8 up, isn't it? It's both. So to work out the x coordinate, you can either start from A and add it, or you can start from B and subtract it. It doesn't really matter. I think I just started from A, so the x coordinate would have been 6 plus 2 squares, right? So 8 and 8. So that's 16. What's that? 22? Yeah, 6 plus 8 plus 8, exactly. Yep, 22. And then, so that's the x coordinate. The y coordinate, don't start from the bottom, because again, you see how you've got 1 square. Let me get a different highlighter. We've got 1 square up, but then this is the one that overlaps, and you don't know how far that is. So I wouldn't look at it like that. I would look at it from the top down, because that is exactly 2 squares down, isn't it? And they're both obviously 8. So starting with the 36 for y, you'd have to take away 8, take away another. I mean, obviously you can write that as 16 if you want, but it should give you 20. Okay, so the y one you do have to start from this side, because otherwise you don't know what the overlap is going up. So scroll down. You should get 2220. Yeah, 2220 exactly. Bit of a random one, this one. I mean, 5 marks, quite a lot of marks, but it's a bit random in terms of it's not necessarily repeated topic. It's just kind of general coordinate geometry, isn't it, that question? For 22, just to get the number 22, let me have a look. Question was that? Question 6. Three marks for 22. 3 marks for basically getting one of the coordinates. Yeah, I'd call it coordinate geometry. I think that's what I'd call it, I guess. I would put it under that. Yeah, you get 3 marks for getting 22, and then obviously a mark for them working out the other, like doing this process for y, and then obviously the final mark is for both. So yeah, 3 out of 5 if you just got one of them, which I'd assume you'd probably get the x first, wouldn't you? Okay, question 7. We've obviously got some kind of transformation here. I think this comes up quite a lot. Not necessarily like this, maybe different versions, but you know, when you've got a shape and they transform it in some way, I think this comes up a fair amount on the non-calculator. So they've said shape t is reflected in the line x is -1 to give shape r, and then shape r is then reflected again in the line y equals -2 to give shape s. So what I would probably do is I'd probably just map it out just to look at it. I like to visualize things, to be honest. You don't have to, but I think I probably would. Just so I can see exactly what's happened. So just be careful that you've got the right lines. X is -1 is actually a vertical line, isn't it? So that's, start with this corner, 2 across, so 2 across this way. And then the actual triangle is 2 squares, isn't it? That'd be there, and obviously 2 high, so then something like this. So that would be, what do they call that? R. Shape R. And then they said they've reflected it again in y is -2, so that's a horizontal line across here. And then just be careful because you've got the axis as well. It's actually 3 squares different, isn't it? So 3 down, and obviously it'd be then upside down, wouldn't it? So now this is where, what was it, shape S. Okay, so now just looking from, they've said describe a single transformation that will map t to s. Just be careful which way around they've said it is t to s. I would have said, there's actually 2 answers for this, to be fair. My first thought was a rotation, which you can kind of see. So first of all, you could say rotation. That's obviously going to give you 1 mark. You then need to describe the rotation. So it's obviously 180 degrees, isn't it? 'Cause it's flipped completely upside down. You don't need a direction, clockwise or anti-clockwise, because if it's 180, then technically it would work for both, wouldn't it? Clockwise, anti-clockwise. Okay, so just 180 degrees. If it was 90 degrees, then you would have to specify clockwise or anti-clockwise. And then also we want to have like the center of rotation. Now in this case, because I've drawn the lines, the center is just where it overlaps. So that's kind of easier. As I said before, if you've got tracing paper, you can just test it out. But yeah, it is just that. So I would say, what's that? -1, -2. That's one of the options. Now, you can actually say something different. The other option, or you could say an enlargement. I know it's not changed size. That's fine. You could say an enlargement because the fact that it's flipped, like it's not only upside down, it's also in the kind of opposite quadrant, isn't it? So your scale factor would be -1. It's not changed size, it's still the same size, so multiply it by 1. But it's a negative, isn't it? That's what happens in a negative scale factor. Again, you'd have to say the center of enlargement, which is actually the same thing, so that's fine. So either of those, if you just say how many, I would imagine the rotation is 1 mark, and then the information is about, but let me see. Oh no, hang on. They've said you get 1 mark if you say rotation 180 degrees, or rotation and then the center, -1, -2. So if you've just said rotation and nothing else, they won't give you any marks. That's actually kind of mean. You have to specify. Same with enlargement. You have to say enlargement, either enlargement scale factor -1 or enlargement center -1, -2 to get 1 mark. Interesting, okay. Yeah. So no, you wouldn't, yeah, I know, I'm surprised by that. I thought you would get a mark for rotation and then the other mark for the other 2 things, but no, it has to be more than just rotation or more than just an enlargement. How did I find the number of degrees? I mean, to be honest, just because just looking at it, I just knew that was 180. But what you can do, again, if they should give you tracing paper, is you could kind of test it out. I guess it's 180 because you see how the original triangle is completely like flipped upside down. Like technically, if I put it here, that's 180. Like just imagining it in my head, that's a 180 flip, isn't it? It's upside down. I know it's over here, but it's like upside down now, isn't it? If it was 90, I don't know where it would be, but like it would be that shape, wouldn't it? That's 90. well, 90 anti-clockwise. 90 clockwise would be that way. Do you know what I mean? I don't know. I just knew because it was upside down that it was 180. But yeah, you could test it out with your tracing paper and see kind of like how much you've turned it, I guess. Like, oh yeah, that's 180. Yeah, I don't know how to kind of explain that more, I guess. But yeah. Don't know if that explains it enough. But yeah, whenever they say describe a single transformation, you have to give not just the transformation, but information about it, isn't it? Sometimes it's even 3 marks with all the information that you can write down about it. Okay, actually question 8, we've got another ratio one. I think ratio tends to come up a lot, but it is a bit random, isn't it? Depending on how it comes up, so that's not massively helpful. But it comes up, I think, quite a lot. I mean, also in all 3 papers, but in obviously non-calculator, you can work it out a lot. So the perimeter of a right-angled triangle is 72 centimeters. I'm actually going to draw it just because we're going to need to look at it in a minute. Just going to put it here. The sides, the lengths of its sides are in a ratio 3 to 4 to 5. Work out the area of the triangle. So obviously area of a triangle, base times height over 2 or half base times height, however you remember it, same thing, isn't it? That's the area. So what I need to do is I need to know the base and the height. So I'm just going to share out the ratio anyway. Obviously it will give me all 3 sides, but I'm going to share it out. So when we share out a ratio, we add them up. So 3 plus 4 is 7, plus 5 is 12. Then you divide, do it over here, you divide the total by the total number of parts, so that would be 6. So what we're saying is it's 6 centimeters per part of the ratio. So then you've got the side that's 3 parts would be 18 centimeters. The side that's 4 parts is obviously 24. And the side that's 5 parts would be 30. Now this is why I've drawn it, because you need to know, obviously you know all 3 sides, but you need to know which ones are actually relevant to the base and the height. So hopefully you know this. Obviously a right angled triangle, the hypotenuse is always the longest side. So that would be the 30, or the 5 part side, wouldn't it? That'd be the 30. The base and the height doesn't really matter which way around you put them. So let's maybe go based on my one. I've done that one taller, haven't I? What was that? 18. So you'd have to also figure out, once I've shared out my ratio, actually which 2 sides are the relevant ones. It's the 3 part and the 4 part ones, so the 24 and the 18. Now I can obviously work out the area. 18 times 24 over 2. You can work this out however you want. I think, I don't know, I divided 1 by 2 to start with, or you could just obviously do 18 times 24 and then half it. It's up to you, but I didn't really want to do that. So I think I just halved the 24 to make 12. I did 18 times 12. That's what I did, and I think it should give you 216. However, you work it out, you should get 216. So yeah, the only hard thing about that is just knowing which of the 2 sides are actually relevant. Okay, 4 marks though, so quite a nice number of marks in terms of just a bit of ratio and a bit of area of a triangle. Okay, question 9. There's always some format of this type of question, isn't there? Obviously, you're going to get some kind of indices. So write down the value of 36 power of a half. You just need to remember power of a half means square root. I'm just right. You don't have to write that because there's only 1 mark, but just to show you square root, so it's obviously 6. Write down the value of 23 to the power of 0. This comes up so much, not necessarily 23, but just any number or any letter to the power of 0. Bit of a trick question, but the answer is always 1. I can draw a nice 1. Oh, that was even worse. Anyway, 1 is the answer. Then we've got work out the value of 27 to the power of negative 2/3. So this is negative and fractional powers. I like to do the negative first. You can do the negative at the end, but I like to do it first just because I feel like I'll probably forget otherwise. So the negative power makes it the reciprocal. So when it's a whole number, just put 1 over. 1 over 27. So I've dealt with the negative, now it's to the power of 2/3. The denominator, as we kind of did in part A, is the type of root. So in this case, cube root. And you probably recognize that because hopefully you know 27 is a cube number. And then the numerator is just a normal power, so then square it. So we cube root both numbers, obviously one cube root. The cube root of 1 is obviously just 1, the cube root of 27 is 3. They won't make you, I keep saying this, they won't make you cube root or square root any numbers that are not cube or square numbers in the first place. And then obviously square it, so we square both numbers. So, I mean, the 1 doesn't really make much difference as it's still 1, and then over 9. This is a really nice question if you can just memorize kind of what to do. And if you can write a decent straight line, that'd be great. There we go, 1 over 9. Okay, question 10. The table gives some information about the heights of 80 girls. From what I've seen of these past papers, you're either going to get some form of cumulative frequency or a box plot. To be fair, I think last year was a histogram, but most of the time it's cumulative frequency, but there could be a box plot. So in this case, we have a box plot. So they've given us all 5 pieces of information exactly as we need them to draw the box plot. So we just literally have to draw on those lines. Just obviously make sure that, double check the scale if it's anything kind of odd. In this case, it's not. It's just 1 square is 1 centimeter, so that's quite easy. So I'm just going to map this out. So you get a straight line, get your ruler and do this. So 133 is obviously 3 across. I do this a bit smaller. You don't have to do it a bit smaller. I don't know. I just do it that way. 170. Obviously mine's it's quite hard to get mine straight, but yours will be a lot nicer than mine on a piece of paper. Lower quartile, 145. That's meant to be on the 145 exactly. Upper quartile, 157. These are just easy marks, these. And then median is 151. And then you just have to join up the 3 in the middle as a box. Again, hopefully nicer than mine looks. And then obviously the others are kind of like these kind of like whiskers or tails or whatever you want to call it. So draw a line in the middle. Something like that. That will be your box plot. 3 marks. I think it's quite nice for 3 marks, really. Then obviously we have a part B as well. So work out an estimate for the number of these girls with a height between 133 and 157. Now, if they ask you this question, it will always be based off of numbers from the table. You see how we've got the least height, and then what was it? The upper quartile. They won't just choose random numbers because it'd be kind of hard to figure that out, right? Because we don't know the distribution. We need to then reference, okay, the least height is obviously like 0, isn't it? The first person or whatever. The upper quartile is normally 75% of the data. So we're going from person number 1 up to the person that falls at like 75%. So they've chosen that deliberately. So basically what that's saying is the number of girls, I just need to work out, because that's like 0, isn't it, effectively? 0 to 75. I need to just work out 75% of 80. That's basically what it's asking me to work out. Okay, they won't choose random numbers. They'll choose numbers from either the box plot or the table if they've given you a table. So what is 75% of 80? Or you might have thought of it as 3/4. That's the same thing, isn't it? So you might know what this is anyway, but I'm just going to write down something to get a mark for doing the working. Divide by the denominator times by the numerator. So that's 20 times 3 is 60. 60. So it's quite an easy one, that one, in terms of, as long as you know that they will only mention numbers that are on the table or are some of these main key points, upper quartile, maybe a lower quartile, things like that. So 5 marks all in all for that one. Okay, question 11. We have got a circle theorems one, but it is question 11, so I guess they're not classing it as too difficult. So we've got A and B are points on a circle centre O. BC is a tangent to the circle here. AOC is a straight line. And then they've given us the angle ABO is X. So that one I'm going to draw, right? Because they haven't drawn that. So you can always annotate it however you want. It really doesn't matter. So A to B to O. So this one here is X. Find the size of angle ACB, obviously in terms of X because we don't have actual numbers. A to C to B. So this one we want to find out. So we're working our way across. Obviously they've said give reasons for each stage of your working. I think it was 2 marks for the reasons, so it's definitely worth writing them down. The way that I started was this triangle here, ABO. This is a radius, but so is this. So is that. So that is an isosceles triangle, which means, therefore, that angle OAB, or if you want to see BAO, whichever one, is also X, because it's an isosceles, isn't it? Isosceles triangle. So this one here is also X. Is ABO not the whole of B? No. No, it's not the, as in you mean all of that. It's not all of that, because that would be angle ABC. You see what I mean? So you just follow the letters as they've said them. If I get a highlighter, you see I go from A to B and then I go to O. Do you see how that's then the angle between? So like just literally follow the letters. Yeah, it's just that small angle. Okay, so the reason why I did that is because then I thought, oh, well, I could then obviously work out an expression for the other part of the triangle, right? Triangles add up to 180. So what's that? AOB would be 180 minus the other two, so 2x. I mean, the reason is angles in a triangle just generally. 180. So that's that one. I can't write that there, but that's that one. The reason why I wanted to know that is then because AOC is a straight line. Obviously, angles on a straight line add up to 180. So I can work out the other side, can't I? Which is BOC, which is technically 180 minus the other one. So if I were to simplify that, see how the 180s would like cancel, but then just be careful, that's a double negative, isn't it? Obviously it can't be a negative angle, right? So that becomes just 2x again, doesn't it? And that was what was the reason, angles on a straight line. It feels kind of tedious to write this, but it's worth the 2 marks, I think. I've not even used any circle theorems yet. Okay, so that's that one. That one here is, I could probably write that in 2x. Now, the reason why I want that is because if I look at triangle OBC, now I'm going to use one circle theorem, basically. One circle theorem. The angle between a tangent and a radius is 90 degrees or perpendicular, isn't it? So OBC is 90 degrees. And then you just write that. Angle between tangent and radius, or radius and tangent, doesn't really matter which way around, is always 90. Now the reason why that helps me, we're basically almost there now, the reason why that helps me is because then if I just look at that triangle, I've got 90, I've got 2x, and then the other one is the one that I want to know. So now I can just use angles in a triangle again. So what was that? What do they call it? ACB. ACB is therefore 180 minus the 90 minus the other 2x. Obviously now you can simplify that. I'm just going to scroll up, I know you can't see it, but this is the last bit anyway. So that would give me 90 minus 2x. That's your answer. What was that? I guess I probably don't really mind if you don't say it again, but angles in triangle is 180. So that's my reasons. So it's 5 marks. It's a lot of marks, but basically it's 3 marks for the working, 2 marks for the reasons. So it's not a lot of working in that sense. Is there another way to do it? Let me see. I'll have a look at the marks. Normally there are different ways to do circle theorems ones, aren't there? But let me have a look. Oh, there's probably a more direct way, actually, now that I'm thinking about it. There's probably a more direct way. Yeah, there is. There's a more direct way that I didn't see. So what you can do, I'll do it in a different colour, is if you look at the whole triangle, I was thinking that's quite a lot of steps for only 3 marks. If you look at the whole triangle, like this to this to this, that whole thing, right? So you'd say the same. You'd say that this angle is x, right? So you say it's kind of the same, but skips out the middle bit of this straight line, basically. BAO, or what did I call it? I called it OAB before. Same thing, right? OAB, you'd still say, right, that that's x because of the isosceles triangle. So that's this one here. Do you see how if I know that one, and then this one here, you could just put it together as one angle? You could say the angle ABC is x plus 90, isn't it? And then you could just go straight into the, yeah, that would make more sense. You could go straight into the triangle. So angle A, CB is 180 minus both of those. X plus 90 plus X. Yeah, that would be more direct, wouldn't it? And then that's obviously 2x plus 90, so then you still get 90 minus 2x. Yep, that would be a different way. You might have done it that way. That would actually be faster, wouldn't it? But yeah, I guess that's a reminder sometimes to try and zoom out of it, try and look at the bigger picture, because I didn't see the bigger picture of it being a triangle as a whole. Obviously, that would have been faster. So yeah, you can do it that way as well, for 3 marks. And obviously then you need the reasons. So yeah, you've got kind of 2 ways to do it there. But yeah, circle theorems is kind of a hit or miss question, I think, just generally. Question 12, algebraic proof. I think, again, this is one that comes up, seems to be quite a lot in non-calculator. So, prove that the square of an odd number is always one more than a multiple of 4. This is an ideal question, I would say, and also 4 marks. This one is a really nice algebraic proof question, I would say, because it works with the 3 steps I normally take. So my first step is what number, if they've not already given you some kind of algebra, right? What number or numbers are they referring to? In this case, it's just an odd number. So you just have to know that the algebraic definition of an odd number, I normally use 2n plus 1. Yeah, it's quite nice, I think, once you know what to do, once you know where to start, 2n plus 1. Obviously, 2 times any number makes it even, so if you add 1, it becomes odd. You could also use 2n minus 1, 2n plus 3, like any of those, or 4n even plus 1. Do you know what I mean? But I normally just stick with 2n plus 1. All of those are odd numbers. So we're not choosing a random number to sub in. We're using actual algebraic proof. Yeah, Wednesday I've got a video going up that's like 15 minutes. It's not a live, but I've got an actual video. I think it's about 13 minutes of like the key things I think to cover. That will upload, I think, Wednesday afternoon. Yeah, but also I will be doing a live on Wednesday anyway, so that's fine. You can also come and ask some questions. But yeah, I have like a kind of last minute. Well, I don't know. This is what I was going to ask you guys. I'm obviously doing one now. Do you want, because it's basically Wednesday, isn't it? Do you want to do another paper on Wednesday, or would you rather have that time as like a Q&A? That's what I was going to ask. I don't know if you'd rather do one more past paper the night before, or if you would rather have a Q&A. So I need to check what time the thing's uploading. Let me see. How have I scheduled it for? I've scheduled it for 6, the actual video. I've scheduled it for 6 o'clock on Wednesday. I don't know if you'd prefer a different time. That's like, as I said, a really quick video. If you want a longer video that's already uploaded, it's like 45 minutes. There's a video that's already uploaded, which is most repeated non-calculator Edexcel questions. So the ones that I see that come up constantly, there's a video that summarizes kind of one of each of those categories. Obviously, that's like 45 minutes though, so you could watch that now if you wanted, today or tomorrow. I've also got my predicted paper that I've written that's gone up today. You can look at that today or tomorrow. The only problem with tomorrow, the stream Wednesday. I was gonna do 5 o'clock for like an hour. The thing is, because I have a couple of students that I tutor, so I can do 5 until 6, and then on Wednesday as well, I'll probably come back at 7 and do like the evening kind of time, like now basically this time. So I don't know if you just want a Q&A that day. I don't know if you want. I did already go through my predicted past paper last week, but there wasn't really many people there, so we could go through that again on Wednesday live if you want. It could be a Q&A, it could be another one of these papers. I don't know which you'd prefer. So I'd say either 5 till 6 Wednesday, or 7 till kind of maybe 9ish on Wednesday. Tomorrow, the reason why I won't do one tomorrow is because I have students on a Tuesday. That's why I don't do lives on a Tuesday. What I could do tomorrow, I have time between kind of 4:30ish until 7. So I could do something that time. It's just at 7 I can't do. So we could do. So paper 2, I was thinking to start next week. I'm assuming that after Thursday you probably won't want to be doing maths on Friday. So I wasn't going to do Friday, and I was just going to start next week, so like next Monday. Now what I was going to do with that though is, because obviously paper 2 and paper 3, they're both calculator. And I feel like, I mean, I'm going to have a look through them this week. I've not really looked through them yet, but I feel like topics could come up either paper 2 or paper 3, couldn't they? So what I was planning to do, and I might change this depending on when I do my research this week, what I was planning to do for paper 2 and paper 3 is just do paper 2 and paper 3 every week, because I guess technically they're both calculated topics, aren't they? So it could mix up. So I was basically from next Monday going to just do maybe like Monday paper 2, Wednesday paper 3, then Thursday back to paper 2, and do you know what I mean? Because they're just calculated generally, aren't they? They're both the same. Whereas obviously paper 1 is quite isolated. You want to do paper 1 before the exam? Yeah? Do you want to do one of these papers? I don't know if you've looked at my predicted past paper. We could go through that. Or do you want to do like, I guess it would be, this is June 2018, so it would be the November 2018 paper on Wednesday if you wanted to do an actual past paper. It's up to you guys, really. Whatever kind of works best for you, isn't it? So yeah, I might do one tomorrow, some point earlier. I don't know, it depends if you've done my predicted paper or not yourself anyway. If you've already done it, there's no point us kind of going through it, but 2018. What topic are on it? I guess, I mean, a lot of the same types that are on this, right? Let me see. I mean, that was the only one that we, I'm going kind of in chronological order, but we could also do different ones. Yeah, I do have a kind of last minute revision video that's going to upload that day anyway. So, but that's not a live, right? That's just a video as well, additionally. Where is it? November 2018. It's either November 2018 or the June ones, because we've done everything else. We've done all the others. The 2017 ones. Either November 2018 or June 2017, November 2017. One of those three we could do. That's the only ones that are left, basically, for paper 1. Let's see, so there's index laws. They've got some kind of like rearranging equations, just general percentages question. What's that? Worded inverse proportion. There's speed, distance, time again. They've got linear simultaneous equations. We've got kind of like a area one where you've got, well, I might as well just put it here and you can see it then. That would be easier, wouldn't it? You see what I mean? Some kind of area ones, different circles. They've got obviously basic trig. What's this? Box plot and cumulative frequency. As I said, that always comes up. More cumulative frequency questions. Simplifying algebraic fractions, factorizing. That looks like difference of two squares to me. What's this? Some kind of percentage one again. Another circle theorems one. You can see it's kind of consistent, I feel like. Describe fully the single transformation again. Obviously more fractional indices, negative fractional indices, that type of thing. Surface area to volume ratio. Recurring decimals to fractions. What's this? Find the coordinates of the turning point of the curve. 4 marks. You've got graph transformations. You've got functions. Functions tends to come up a lot on non-calculator. Surds, obviously, again, another topic that comes up a lot. And they've got a vectors question at the end. And then, actually, I've been through this question quite a few times, but there's a probability question there. That's 6 marks at the end. That's the paper. Yeah, that's the November one. Okay. Yeah? Okay, let's do that. Yeah, we'll do that on Wednesday then at 7 o'clock on Wednesday. How do I move this whole thing? Yep, so Wednesday. Yeah, let's do that on Wednesday. So that'll be, again, same time, 7 o'clock onwards. But on Wednesday, I probably will do a drop-in session, Q&A quick, or maybe like a last-minute revision type. Maybe not even Q&A, maybe just a last-minute revision for like 45 minutes, I guess. At like 5 o'clock, you can also come to that if you want. Yeah, that probability question at the end is quite hard, but it's It's actually just algebra, really. It's also on one of my videos. I've done videos that are like kind of a bit of a series that was like hardest Edexcel questions, but on particularly there's one video on probability. There's also one video on vectors, so you can also look at those, things like that. So that question, that specific probability question is on one of my videos. So yeah, I think it probably ended up being a quadratic, didn't it? But yeah, that looks like a good paper for Wednesday, so we'll do that. I don't know if you want one tomorrow, but it would have to be earlier, as I said, because I have got other things at 7, so it'd have to be like kind of 5 o'clock, 6 o'clock-ish. So I could do one then. It just depends if you guys want to do that or not. I don't know what other exams you have as well. Yeah, okay, so we were saying we start with an odd number. That's the first thing. Step 2 is then what calculation are they asking me to do? In this case, it's just the square, isn't it? Now, don't think it's just 2 squared and 2n squared and 1 squared. It's not. It's like double brackets, isn't it? I feel like a lot of algebraic proof is expanding brackets, double or triple brackets. So that's quite nice. So expand all. I'm still not even worried about what I'm proving yet. Don't worry about that until the end. Expand it all out. 4n squared plus 2n plus 2n plus 1. Obviously, then simplify that. This would already give you, I would imagine, 2 marks at least, just for doing this, even if you weren't sure how to prove it. So we're going to then, now that I've done everything I can, simplified it and all, here we go. Now I'm going to worry about what I'm proving. Now, a lot of the time it is some kind of factorizing at the end. So if you know that, that kind of helps as well. So some kind of factorizing. Now, in this case, they want it always 1 more than multiple of 4. So you can just factorize part of it. You can factorize the whole thing. In this case, I would only factorize kind of partially. So proving a multiple, you want to factorize out that number. So in this case, multiple of 4, I'm going to factorize out the 4. So that leaves me with n squared and then plus n. But the last thing, I'm not going to factorize out 4 from 1, right? That wouldn't work. Is I'm going to leave that 1 there, because you see how this bit, whatever's in the brackets, I don't really care what's in the brackets, as long as I then multiply it by 4, by definition, it is a multiple of 4, isn't it? That's just by definition. And then this is plus 1. Do you see how that's then 1 more than a multiple of 4? Yeah, that's fine. Okay, perfect. So we won't do one tomorrow. We'll do it on Wednesday then. That's good. So yeah, that's what I would say. 1 more than a multiple of 4. I think you need some kind of statement at the end. So I'd probably put therefore, and then I'd copy this bit. Just copy the sentence they've said. Always 1 more than a multiple of 4. But I think that's quite nice. As long as you know where to start, there's quite a consistent question, that one particularly. I know some of them aren't for algebraic proof, but that one is quite nice. So question 13, as we said, surds comes up quite frequently, obviously on the non-calculator one, because otherwise you would just put it in your calculator, wouldn't you? So for this one, we've obviously got single brackets. This can be written in the form a root 10, where 8 is an integer. Find the value of a. There are 2 ways to do this. You can expand it first and then simplify it and all that. But actually what I did is I kind of like to simplify everything first and see what happens. And I'll show you why. So obviously root 5 we can't simplify. Root 8 we can split into root 4 and root 2. And then root 18 into root 9 and root 2. So then obviously square root those numbers that you can square root, 2 root 2 and 3 root 2. The reason why I didn't want to expand it first is because you see how they're both root 2's, so I can actually add them. And then if I then multiply now, I'm actually only multiplying like 1 term, not 2. So it would work the other way. You can can kind of expand it straight away, that's fine. But I guess you just have a bit more work. So now we multiply it, we get 5 root 10, that's where the root 10 comes from. They ask specifically for the coefficient, the number in the front, which is just 5. So that's what I did, but as I said, you can expand it first. I also didn't really want to have to do 5 times 18 either. Like personally, I didn't really want to deal with that. So that's why I simplified first. But it doesn't really matter. So that gives you 3 marks. Yeah, a lot of them have multiple different ways. You just got to try and pick the path of least resistance if you can kind of see that path. That would be ideal. Question 14, we've got proportion. I've also seen, I mean, you know, proportion could also come up in any of the papers, but I do seem to see it a lot in paper 1. So we've got here effectively what I'd call double proportion. We've got 2 relationships. So y is inversely proportional to d squared. Obviously you get your matching pair when d is 10, y is 4. And then d is directly proportional to x squared when x is 2, d is 24. Find a formula for y in terms of x. Normally, if it's like kind of a straightforward one like this, as in it's laid out quite nicely, this also splits into 3 steps. Obviously we're just going to do them both twice, right, for each relationship. Step 1 is to write down the correct formula, obviously using the letters they've given you as well. So for the first one, y is, so y equals inversely proportional. That's when you do k over normally x, but obviously in this case, d squared. And then for the second one, you can do them both separately or both at the same time. The other one is direct proportion. So d is, and then it's normally, well, I say k times x, but because we've already used k, I'm going to use a different letter. K times x squared. That's the same, right? K and c are just constants. Obviously, I didn't use the same letter for both because they're not the same number. I don't think they'd care if you did use k both times. I don't think they'd really care, but just technically, right? So that's step 1. That's quite straightforward. Step 2 is then to use the matching pair of values that they've given you to work out k, or in this case c, to work out that constant. Make sure you obviously sub them in the right way around because they've written them the wrong way around for whatever reason. So it's 4 for y, and then 10 squared. Do you see how I can just solve that to find k? So k is 400 in that particular case. What I would then do is I would go kind of therefore and rewrite the equation. So y is not k over d squared, it's now 400 over d squared. So that's the relationship for the first one. The second one, we've got d is 24, and then 2 squared. So I'm just going to write it like that. So then you can see for that one it's 6. That's why I didn't write k as the same letter, because technically they're not the same value, are they? And then I rewrite my equation, so that's actually 6x squared. Okay, I've done that. Now step 3 is to actually answer the question. What was the actual question? In this case, we're not working out values, we're literally just putting the 2 equations together. So they've said, find a formula for y in terms of x. What that means is y is the subject, and then everything else, obviously there's numbers, but it's like something x. So that means, in this case, there's no d. We can't have another letter. So luckily you can see that d is where they overlap. So I would just literally take the second one and substitute it into the first one. So that would be y is equal to 4, this is step 3 here. 400 over, just remember that it's all of that squared, so 6x squared, and then that squared. Now, they have said give your answer in its simplest form, so I would probably, I guess I would expand that, as in square it, literally. So y is 400 over 36, but also that becomes x to the power of 4, doesn't it? Because you're squaring it. Okay, I think what they mean is that you could simplify that fraction. I just divided both by 4, basically. 100 over 9x to the power of 4. That's what I put as my answer. Now, I think there were different versions of the answer, so let me have a look. I think there were different formats you could put it in. Question 14. This is the main answer, like the main one they've chosen, but they've said or equivalent. They have said you could put it as a decimal. I don't know why you would. Like, I genuinely don't know why. Like, as in 100 divided by 9, you could work that out. I obviously wouldn't do that, because it's non-calculated, but they've said that you can. Yeah, or equivalent. They've said or equivalent, but then surely it has to be simplified, so they've not given any other examples. I would have gone with this. I think that's kind of the obvious answer there. I guess maybe if you wrote it like this, they would accept that as well, obviously, but again, I don't know why you would. I would just leave it as it was. I think it's more just making sure you simplify the 436 bit, or at least expanding this bit out, maybe. Yeah. Up to here, that's 4 marks, by the way, 4 marks, that bit there. And then the final mark is for, obviously, oh, what is going on? The final mark is obviously for simplifying it. You got 200 over 3, oh. Yeah, I don't know where the 3x squared came from, to be fair. Oh, I guess you halved it. Oh yeah, did you just not square this bit here? At the end. How many marks we're getting to 6x squared? 6 squared. So I'm just having a look. Actually, let me just go back up. So the marks are these. Let me my pen out. They said 1 mark for setting up a correct proportional relationship. So for example, that could be 1 mark. You've not even written anything really. They've then given the 2nd mark for setting up a second proportional relationship. So I guess that's 2 marks. The 3rd mark for a process to find one of the constants. So this bit, like this step 2 here, if you do one of those, that's 1 mark. So let's say that one. And then they kind of skip after that point. They kind of skip. So that's 3 marks there. They then skip. The 4th mark is for full process to find y in terms of x. So basically you subbing it in correctly. So like this bit, that's the 4 marks. And then the 5th mark is for like simplifying it. Right, let me see. Yeah, that's what I was thinking, is that you subbed in the 6x squared but didn't then square the 6x squared itself, because it is technically d squared, isn't it? Yeah. Don't know if that would be definitely 3 marks. I don't know if that would be 4 marks. Both constants must come from the correct process. Yeah. For full process to find, it says for full process to find y in terms of x, so I feel like that would have to be correct. I think I would probably give it 3. I don't think you would get the 4th mark because you didn't, like if you didn't write the 2nd square here, I think that would be 3. Yeah. This is why I kind of always rewrite the equation at the end here. Like once I've worked out k, I always rewrite it just so I can see exactly what I'm working with. Yeah, it's annoying because you would have got there otherwise. Yep, you can rewatch this. When we finish, it will basically upload itself. And obviously if you go onto my channel, I don't know if you can see the live section, or I've got like a lives playlist. You can have a look and it's named whatever this is named. What is it? June 2018. You can find it. Yeah. So you can watch this later. You can watch it either now live or you can watch it later afterwards. That's fine. Yeah, I thought, yeah. So question 15. We've got, again, some kind of factorizing. Hopefully you can recognize what this is very specifically. This is completing the square. This is the difference of 2 squares. Difference of 2 squares. We've got 2 squares, a squared, b squared, and the difference. So they've used letters here. Obviously it works also with numbers, doesn't it? We just need to remember one is plus and one is minus. Difference of 2 squares will always come up at some point. I can pretty much guarantee that. Now, whether it's paper 1, paper 2, paper 3, I don't know. But it will always come up at some point. Whether it's like this, where it's completely just its own question, or whether it's kind of within another question. I've seen it a lot with algebraic fractions, maybe like solving inequalities, like anything like that. It could come up in any other question, but I would pretty much guarantee will come up somehow. So make sure you know how to do difference of 2 squares, because it's just such an easy mark. Now, they have then said hence, so that's therefore, or otherwise, I would probably ignore the otherwise. Using your answer from part A, simplify this. Now what I want you to recognise, I know this is a lot more going on, is that this is also difference of 2 squares. And I'll highlight it to show you. This bit, let's just match it up with A squared. And then the second bit is something squared, match it up with B squared. Do you see what I mean? And then I would just sub it in like that. So I would say, you don't have to write it like this, but just to really explain it, A on its own would be the x squared plus 4, that bracket, obviously not squared. B on its own, without being squared, would be the x squared minus 2. So then, just whatever I've written for part A, do you see how I could just sub in that? I know it's kind of long, but so for A, it'd be x squared plus 4, and then it's plus, and then B, x squared minus 2. We're obviously going to then simplify it, right? That's the first bracket. And then A again, x squared plus 4 minus, this time it's minus. I'm going to put a bracket here just to remind myself I'm subtracting both of these parts. And again, you can kind of like go, well, that's B, that's B. Do you see what I mean? Like that's B, that's B. There's my pink. That's A, that's A. You see what I mean? Like I'm just subbing it in the same way, just with a more complicated version of the question. Now, obviously I've done that, I'm going to expand it, you know, well not expand, but I'm going to simplify it, collect the like terms. So in the first one, we've got 2x squared plus 6. No, not plus 6, plus 2, because we're subtracting the 2. 2x squared plus 2. The second one, the x squareds, just be careful because you're subtracting that second part. The x squareds actually cancel out, don't they? They're not there. And then you've got 4, subtract minus 2. So that's a double negative. So that becomes, don't even need a bracket there, do we? That becomes 6. I mean, if you get the same, because they did say hence or otherwise, if you get the same answer as me, then it's fine. As long as you get the same answer at the end, you'll get the marks. But I was just kind of relating it because they said hence. Now, the only thing with this, though, is they said simplify fully. This is not fully simplified. So what I mean by that is you see how I could also factorize out a 2? So that's the trick bit. I always miss that bit out. Technically, you could factorize it like that. So accept this, or if you expanded it, you might get this. They'll also accept that. Either of those two answers they'll accept. Okay. What topics do I predict come up? I have got predicted paper. Hang on, let me see if I can link it. Let me just send it in the comments. Give me a second. This is my predicted paper, which obviously includes the topics that I think. Oh, I mean, this is my first year, so I don't have any kind of stats to give you, basically, so it's up to you. What I've done is I've gone through all of the Edexcel previous past paper ones, and I've kind of given a tally to which topics came up, and then from there I just kind of picked the most common ones and made a paper. So again, it's not like, you know, it's not necessarily that I'm not saying that this is exactly what's going to happen. I'm not saying that other topics won't come up, because they obviously can. It's just a prediction. Where's my list of topics? I had a list of the most common topics as well. It's in my most repeated non-calculative questions video. Like the start of it has a list. I can paste it. Give me a second. It's quite a lot of topics, to be honest, but obviously it's, you know, 20 to 25 questions, so, and some of them they have 2 topics in one question. To the second part of my list. This is the most common. I mean, obviously other things come up, right? Other things do come up. Don't just rely on this for your work, for your revision. You should have revised everything else as well. Oh, it's all stuck together. Hang on. Some commas in there. Oh, it won't let me type that many things. Okay. To paste it into in 2 messages. That's the first bit, and then the second bit. Yeah. Those are the ones I think are the most common. This is, I'm talking about Edexcel. If you're not doing Edexcel, I haven't looked at the other papers. So this is particularly Edexcel, right? These are the most common ones. Most common, okay? There are obviously loads of other topics that do still come up, can still come up. These are kind of just the top ones that I saw repeated the most. Okay, so again, I'm trying to explain this is not an exclusive list. This is not the only stuff that will come up. This is just some suggestions. Yeah, Wednesday we'll do a paper at 7 o'clock, same time. 7 o'clock we'll do the paper. Okay. All right, so that was that one. If you got the same as me but you did it a different way, that's fine, as long as you get the same as me at the end. I mean, I'm not recommending cheating, obviously. We're just kind of using patterns to predict. But again, it's quite risky because what if it's completely, not these topics? So that's why I'm saying, like, don't just revise what I've just said, because I'm not a teacher, I don't know. I mean, obviously the teachers also, I'm assuming, don't know exactly what comes up on the papers either. I don't know if they see it in advance. I've not obviously seen anything, so I don't know. But based on historical kind of data, that's the most common topics. If you you're at the point where we've only got a couple of days left, you want to focus on not the whole syllabus. That's what I guess I'd focus on. But again, it could be anything. Could literally be, I mean, anything apart from iteration. Probably not iteration, right? Because I don't think they'd make you do that non-calculator, but technically anything, right? Okay. So we've got, by the looks of it, probability and again ratio again. So there are only red counters, blue counters, and purple counters in a bag. The ratio of red counters to blue is 3 to 17, so red to blue there. Sam takes at random a counter from the bag. The probability that the counter is purple is 0.2. Work out the probability that Sam takes a red counter. All right. So, obviously, all probabilities add up to 1. You can work with decimals if you want. I think what I did is I just prefer, when they're not giving you like a quantity, I like to use 100, just to make it nice for percentages, nice for ratios, nice for all of that kind of thing. So 100, let's say there's 100 counters in total, right? Roughly. If there's a total of 100, I can't share out, I'm not going to immediately share out my ratio, because if I did that, it would be saying that there's only red and blue, but there are also purple. So I first have to get rid of the purple. If purple is 0.2, that's 20%, isn't it? So purple is 20%, which is hence why I use 100, 20. So if I take that away, do you see how red and blue is therefore the 80 left? I don't know there's 100, I'm just putting a number there for myself. I don't know that there's 100. But you could also use 1 and do 1 minus 0.2 and then have 0.8 and then use the 0. I just didn't really want to use decimals, that was the only reason. So I just scaled it up by 100, if that makes sense. So, because they're not asking me for how many counters are there at the end, because obviously I can't work that out because I don't know. They're asking for a probability at the end. I did it because I didn't have a quantity, right? So I was like, oh, I kind of want to apply, and I didn't want to use decimals. That's how I would explain it. I didn't want to use decimals. You can use decimals if you want, but then you see how you have to then share out the 0.8 into a ratio, and I was like, you can. It's not like impossible. I just would rather not. So I scaled it up. Like, imagine that's 100%. So therefore the purple is 20%. So therefore you can look at it as percentages if you want. Or just 100. So then I was like, okay, red and blue is 80%. Now I'm going to share out the ratio. So you see how if you add that up, luckily, makes 20. 80 divided by 20. It would either be 80 divided by 20, or you'd have to do 0.8 divided by 20, which you can also still do, but you might not want to. So then that gives me 4, again, if I'm working with percentages, 4% per part. Now, what do they ask for? They ask for red. Red is therefore 4 times the 3 parts, isn't it? So 12. You either put 12%, or you can put, as you said, 12 over 100. You can put it as a decimal. You might have got 0.12. Because it's a probability, you can put it in any format, decimal, fraction, or percentage, doesn't matter. So I just used 100 because that was kind of an easy number. You don't necessarily have to use 100. I just felt like it was an easy number to put there. Do you see what I mean? But you could do it straight away with the decimals if you really wanted to. That's also fine. You'd then get 0.12, which is the same thing. So yeah, any kind of version of that, I don't think they'd mind. Any equivalent of that is fine. So yeah, if you don't have numbers, that's when I sometimes think to use, put my own numbers in. Yep, so final answer is 0.12, 3 marks. Okay, algebraic fractions, I feel like this comes up quite a lot as well. I think that was on my list in the non-calculator. So this one's just a simplifying one, which is quite nice. Basically, when you've got already a single fraction and they want you to simplify it, we're just going to literally factorize as much as you can. Now, sometimes it'll be double brackets, sometimes it might be single brackets, so just kind of watch out for that. So the first one's obviously double brackets because it's a full quadratic, isn't it, at the top? It's a full quadratic. So you could factorize it. The other way that I kind of do this is that the denominator is easier to factorize. It is a quadratic, but do you see how it's missing the plus c, like the end number? When it doesn't have the number at the end, that's always going to be single brackets. So I can pull out 2x, x minus 3. Now, because I know how like algebraic fractions works, I know that I'm going to look to be cancelling out one of my brackets, aren't I? That gives me kind of a hint. I mean, obviously you can factorize the numerator anyway, but it gives me a hint that obviously one of the brackets in the numerator must be the same as the denominator. So it kind of gives me a hint that probably this one's going to be minus 3, isn't it? Obviously make sure that does work, but it gives me a bit of a hint. So then I know that that's obviously 3 and 1. It has to be a plus, and then you can double check if that works. Minus 9x plus x is minus 8x. Yeah, that works. Obviously then cancel out, and then there's nothing else you can simplify because you have to look at all of the terms that are left. We've got 3 terms, 3x, 1 and 2x. None of them have a common number, none of them have a common letter, so that's just the answer. You get 3 marks for basically doing all of the factorizing. Okay, let me have a look. How is the number 17? Oh, I don't know what you mean by that. Okay, so let's see. That's algebraic fractions. It's quite a nice one. That's one of the ones where I said sometimes difference of 2 squares can come up here when you factorize it. Okay. Yeah, it's pretty easy, that one. It's a really nice one. Okay, question 18. Here is the graph of y equals sine x. Obviously for the range between minus 180 and 180. On the grid, sketch the graph of y equals sine x minus 2 for the same range. So this is graph transformations, but obviously specifically trigonometric graph transformations. So the only thing we've got is this minus 2, which is outside. You see how they've closed this kind of, if you imagine putting brackets, they put brackets there, haven't they? So this is a translation, first of all, but more specifically, you just have to memorize the graph transformations. This is a transformation in the y-axis. The other way you can tell that with the trig graphs is obviously the x-axis is in terms of degrees, and like much bigger numbers you're not going to get like minus 2 degrees because that would be so insignificant. It'll be like 30 degrees, maybe 15 degrees as the smallest, probably 90 degrees. And then the y-axis is in terms of 1, 2, 3, 4. So minus 2 kind of makes more sense to be on the y-axis, isn't it? Yeah, this is graph transformations exactly. Yeah, so the x nothing happens to, we're literally just going to shift the whole graph down by 2. So just take a couple, like 1, 2, 3, there's like 5 kind of key coordinates there and just move them down. So just be careful of the scale, that would go there. This one's at minus 1 already, so minus 3, 0 to minus 2, 1 to minus 1, and 0 to minus 2, you can see that there. And then you would just draw it, obviously sketch it with a pencil. Just going to try my best. Because they have said, oh, that was off. They have said sketch it. It doesn't have to be exact, right? As long as your, some coordinates are pretty accurate, then they can see that you got the gist of it. So there, it's just literally the whole thing goes down by 2. That's it. It's really nice. 2 marks. But yeah, you just have to memorize the graph transformations to know which ones they are, isn't it? That's the thing. Okay, question 19. I feel like some kind of straight line graphs, maybe perpendicular lines, comes up a lot as well, whether it's at the end of the paper like this one or whether it's kind of at the start of the paper. Obviously that changes, but this seems to be quite common, some kind of straight line graph situation. So the point P has coordinates 3, 4, the point Q has coordinates AB. A line perpendicular to PQ is given by the equation 3x plus 2y equals 7. Find an expression for B in terms of A. Again, that just means B is the subject, everything else A. Now, they've not asked us to find A and B as actual numbers because, again, if we only have enough information to create one equation, you can't solve for 2 letters. So they are not asking us to find out what A is or what B is, because we can't. They're just asking us to write an expression. So I wouldn't even worry about that, because I feel like that's the bit that you're not really sure about. I would just think, what can I do with this information? Now, I think there's also 2 ways to do this, so it depends which way you prefer. Obviously, a perpendicular line, we know there's some information about a gradient, isn't there? So what I would do is I'd probably rearrange this to get, you can only look at the gradient if it's in this format, isn't it? You have to rearrange it. So I'm going to get y as my subject. So I'm going to minus the 3x. Obviously 7 is still there. And then divide by 2. That'd be minus 3 over 2. I would leave it as a fraction if I were you. Plus 7 over 2. So the gradient is minus 3 over 2. Now that's the perpendicular line, isn't it? Gradient of the perpendicular line is minus 3 over 2. Therefore, the gradient of my line, PQ, is the negative reciprocal. So that'll become positive and go to 2/3. How many marks is this? I think they gave you the whole page, so 5 marks actually, this one, 5 marks. How many marks for this bit of the question? I don't know if that's what you were asking. You get 1 mark for kind of all of, like, either rearranging it or writing that, or yeah, this is kind of like the 1 mark, that bit there so far. You then get another mark for writing the perpendicular gradient, which is 2/3. That's already 2 marks so far that I've done. Now, this is the bit where it changes. You can either set up an equation for the gradient, you know, when you do change in y. If I could write the y over change in x, you could write that, or you could write the y equals mx plus c, find out the plus c, and so on. So it's up to you which kind of way you want to go about it. I think I naturally did the straight line, like I did the y equals mx plus c, but that was just me. I don't know. You might prefer to do the gradient. I could show you both if you want. So the way that I did it was I was like, let me set up this equation for the line PQ. So you always find the gradient first, don't you? So we now know for the line PQ, the gradient is positive 2/3. That's why I left it as a fraction, because then I could flip it. X plus c. Now, to find the plus c of any straight line, you need to sub in a set of coordinates, don't you? So I would sub in the 3 and the 4, because I want to know what plus c is as a number. So I would sub in the 3 and the 4. Obviously, make sure you sub it in the correct way round. So y is 4. And then x is 3. So 2/3 times 3 is just, like, these cancel, don't they? That's just 3. Well, the 3 cancels out, that's just 2. Scroll down. So I've got 4 equals 2 plus c, so c is obviously 2. So then my equation for line PQ is 2/3 x plus 2. Now's the bit where I would worry about, what do you mean an expression for b in terms of a? Do you see how b and a are coordinates as well? I could just sub those in, couldn't I, to this equation that I've now found? If I just sub it in, because b is the y coordinate, so b is equal to 2/3 a plus 2. Do you see how that's an equation? That's an equation for b in terms of a. So that's like the answer. Now you can do it that way. I can show you the other way, which is with the gradient if you prefer. So as I said, using change in y over change in x. So you still need to obviously get to this point here, right? You still need to get to that point. So then you would say the gradient is, you know, when you do y2 minus y1 over, like, this is the change in y over change in x, isn't it? You could use this equation instead. So you go, well, like, equals to 2/3, and then you just choose, can you see that? No. See those coordinates? Both of those coordinates at the same time. So let's say I'm just going to use the 4 first. 4 minus b over 3 minus a. You could do that. And then, in that case, all you would have to do here is just rearrange it to get b as the subject. That's all you'd have to do. So I'd probably cross multiply. So what's that? 6 minus 2a is 12 minus 3b. And then I want to get b as the subject. So I'm going to add the 3b to make it positive. We will add the 2a to make that on the other side, and then take away 6. And then divide by 3, because obviously you need b in terms of a, just as in just b. Do you see how I get the same answer? So you can do either of these 2 options, whichever makes more sense to you. Let me have a look at the comments. Why put point P in the equation Oh, yeah, when I subbed in like this bit here. So the reason why I had to sub in the, what was it, 3, 4? Is that the way around? The reason why I had to sub in 3, 4 if I did it this way was because that's just, if you think about, kind of forget about the context of this question, as in the A and the B, forget about that. Just think about straight line graphs. If they ask you to find the equation of a straight line, you first of all find the gradient by whichever means. Obviously, in this case, we did the negative reciprocal. Then after you found the gradient, you have to find the plus c, don't you, the y-intercept. Right? So, and the way you do that is you sub in a set of coordinates that is on the line. Now, I didn't sub in A and B directly. The reason why I didn't sub that in directly, because obviously I know A and B are also on the line, is because they asked for an equation for B in terms of A. So I can't have any other letters. If I had subbed in, like here, AB directly, I would have also still had a C, wouldn't I? Unless you wanted to rearrange it to make C the subject and then sub that back. I don't know why you would do that. I wouldn't even bother with that. But you might end up with still having C in it, and we don't want to have any other letters because they have just said in the question, find an expression for B in terms of A. That means only B and only A. So I just subbed in the 3 and the 4 to work out, instead of writing the letter C, I could work out the number for C. I don't know if that answers your question. Yeah, and then I subbed in A and B at the end because I then had, otherwise, because you see, otherwise you would have ended up with like that, which is not, they wouldn't want to have C, they want to have an actual number. So that's the reason. But you could do it this way if you prefer this way. I don't know, whichever way makes more sense to you. You end up with the same answer anyway. The point is if it says B in terms of A, it means B is the subject, and then everything else in terms of just A, or obviously numbers. Okay, I think this is the last question actually. Question 20, let me check. Yep, last question, another 5 marker. Oh, again. Now, I think this is quite a nice question, if you know what you're doing with inequalities. I think it's quite a nice question. So here we've got n is an integer, so a whole number, such that we've got 3n plus 2 is less than or equal to 14, so that's linear, it's just like a straightforward one. And also, 6n over n squared plus 5 is greater than 1. Now that's a quadratic, because n squared, right? Find all the possible values of n. So what we need to do is solve both of these individually, and then at the end we'll look at what the answer, kind of where it overlaps. So solve them individually. Obviously the first one's quite easy because it's just linear. It's just a normal equation, it's not squared or anything. So that means just get everything onto one side, have the n on one side and then all the numbers on the other side, right? So I would take away the 2 first and then divide by 3. So that's that one. N is less than or equal to 4. And then this one is a quadratic, but therefore, you know, when we solve quadratics, we obviously need to have everything on one side, 0 on the other. So we're going to have to rearrange this one. How many marks for finding? I'd imagine 1, but I can check. Yep, 1 mark for the first inequality. You get 1 mark for rearranging this as well. And then solving it is another mark. So obviously this one I need to rearrange, right? I'm going to multiply by n squared plus 5, obviously get rid of that denominator. Now, I know that, I don't know whether you're thinking this, but technically with quadratic, well no, with inequalities generally, when you multiply or divide by a negative number, it flips the symbol. Now the reason why I know that I don't need to flip the symbol here, because I know that I don't know what n is, but the reason why I know that this is not a negative is because obviously think about almost like algebraic proof. If you square any number, if it was negative or positive, if I square it, it becomes a positive. So this is positive. And then if I add 5, it's just more positive. So I know for a fact that if I multiply by n squared plus 5, I don't need to worry about flipping the symbol. It was a positive, nothing, don't worry about that. So then I decide, well, which side do I move everything to? I like to have my n squared as a positive, so I'm going to leave that there, and I'm going to move the 6n. So subtract 6n. Now I have my quadratic. So that's 2 marks, right? So this is 1 mark. This is like the second mark, right? Just for rearranging it as another mark. Then obviously we're going to solve it. You can solve it however you want. I would obviously tend towards factorizing. This is probably the point where I just make it equal to 0 and just don't worry about the symbol. We'll put the symbol back in at the end. This one's quite nice. You've obviously got two negatives. 5 is a prime number, so -1 minus 5. And then solve it, so n is 5 or 1. Now, oh, you get a mark for the method to begin solving it, so factorize. So that's like 1 mark there. And then, so you don't get a mark for these numbers, you get a mark for when you put the inequalities back in. So this is the thing where I say, and I mentioned it in my live earlier today, actually, in the Q&A. Just memorize it. So looking at this, looking at when I've obviously rearranged the quadratic, right? Looking at this bit. The format for the inequalities for my answers depends on where the original inequality faced. Did it face the 0? Did it face the quadratic? In this case, it faces the 0. Now, if it faces the 0, it's a linear. It's a range. That's what I'm trying to say. It's a range. So obviously, 1 is a smaller number, n in the middle, and then 5. Well, first of all, it'd be positive those numbers, because if I solve it, see how it was negative in the brackets, it becomes positive, doesn't it, when you solve it? But then it's between them. If it faced the other way, like if it faced the quadratic, then yeah, it would be n is less than 1, n is greater than 5 separately. It would be two separate inequalities, but that's if it's facing the quadratic. In this case, it faces 0. So it's a nice range. So that bit there, and it's the 4th mark is for, technically for the 4 as well, for getting the correct 4 and the correct inequality. And that's the 4th mark. So we're already on 4 out of 5. Now the last bit's actually the easiest bit. You might be able to just visualize it. If you want to draw a number line, you can. If you could just see it in your head, also fine. I'll just kind of show you kind of directly. So this one would be like this, wouldn't it? And then this one would be like that. So where do they overlap? Again, you don't need to draw the number line. I'm just kind of showing you. Now, this one hasn't asked, you still see the question? This one hasn't asked for an inequality as an answer. It's asked for all the possible values of n, the actual values. We want a list. So sometimes they ask for a possible like set of values. That means an inequality. In this case, they've asked just for literally the values. So which values does it include? Exactly, yeah, 2, 3, and 4. It doesn't include 1, it doesn't include 5. It includes 2, 3, so your answer would be 2, 3, 4. That's like the format of the answer they want for this one. They don't want an inequality overall. If you wanted an inequality overall, this would be it, just so you know. Sometimes that's the question, isn't it? That would be your inequality. But in terms of a list of numbers, because that's what they want in this case, 2, 3, and 4. That's the final answer. So obviously, I'm assuming that's the final mark there. 2, 3, 4 is what they're looking for. It has to be exactly that because they're whole numbers. They've just said there's no other kind of possible answer. That is just it. 2, 3, and 4. So yeah, that's the final part of the paper. Oh, amazing. 74 out of 80. That's really good. Yep, so on Wednesday, we will do a live at 7 o'clock. We will go through the November 2018 paper, okay? Paper 1, obviously. Live at the same time, 7 o'clock. Yeah, we worked backwards. So basically, because I started doing these papers in like April, I started at like June 2023, and then every week we kind of worked backwards a bit. You got 75. Oh, that's insane. I mean, I'd look at the grade boundaries, but I'm assuming that's basically a 9. My assumption. What's this? This was June 2018, wasn't it? June 2018. Hang on, I need to divide it by 3 because I've got the numbers, but for all 3 of them added together. Oh, do you think it's... No, that would be so high to get a 9. Oh yeah, that's a 9. Well, as in, obviously, you know, they only give the numbers for... Hang on, let me bring it over here. They only give the numbers for, like, the total, right? So what's this here? This is obviously for all 3 papers, right? So you divide that by 3. If you divide that by 3, you get 67.333. Imagine 68, right? 68 out of 80. and you got 75. Yeah, 70. If 75 is not a 9, I don't know what would be. That would be so high. Because remember, on average, a 9 is on average 82%, which is on average 65. Now for this paper, that's a bit higher, isn't it? We just said 67, 68-ish. For this paper, I would say yeah. Yeah, for this year. Obviously, every year is slightly different, isn't it? On average, you need 65, but that accounts for some years where it's lower, some years where it's higher. So you see how, like, June 2023, you had to get 203 to get a 9. June 2022, you had to get 194. That's like 10, oh well, almost 10 less, isn't it? And then November 2021, you had to get 187. Do you see what I mean? Like, it's all different, isn't it? So for this one particularly, this was, no, that was November. This was June 2018. If you take 202 and divide it by 3, just so you get an average of what a 9 would have been. On average, the 9 would have been 67, 68. On average. Right. So yeah, you'd be definitely into a 9. It just then depends what you get on paper 2 and paper 3, doesn't it? Because they average it out. That's the thing. So yeah. Anything above 70, I would assume, would definitely be a 9. So yeah, if you want to have a look at my predicted paper, have a look at that. I've uploaded the video. You can download the actual paper in the, it's like a Google link doc or PDF or something, so you can download that if you want to have a go at that. But otherwise, we will do, yeah, our next paper will be Wednesday, so the last paper 1 at 7 o'clock. Yeah. Yeah, thanks for coming, guys. Thanks for interacting. If it was helpful, make sure to like, subscribe, obviously share it to your friends. And I will see you on Wednesday. Good luck if you've got biology tomorrow. It sounds like you have that tomorrow if some of you do, so good luck for that. And yeah, we'll see you on Wednesday.